missing anyone? One person?
Anyone who's not here, raise your hand. No
Well,
hand.
we're actually a minute or two, thank you all for coming back so soon. We're a minute or two ahead of the 15 minutes that Jim provided. So I'm Elizabeth Heitman. I am the ethics person on this team. And I'm a faculty member at Vanderbilt University Medical Center, where I enjoy teaching responsible science using cases. And in particular, thinking about contemporary cases, things that are in the news, things that students are likely to be aware of, and things where there's often something more to investigate than what's in the headline. This next session, which I typically do with my student, and we trade off pieces of it in the same way that Jim and Jay did the last session. Because she's ill this morning, I'm going to be doing the whole thing. So if at any time you can't hear me, or there's any question, please stop me, or poke one of them, and they'll give you the high sign. But the goals of this session, the learning goal of this session, and you'll notice that we are modeling in our presentation what we said a few minutes ago, what Jim and Alistair said a few minutes ago, about how to provide a structure for a presentation, to identify the goals, identify the learning objectives. The goal of this session is to think about and work with you so that you'll be able to use noteworthy cases, contemporary cases and historical cases, both, in the teaching of responsible science. With the learning objectives of this first session, to be able to recognize ethical issues in complex cases. And then to be able to make connections among them. How do they link together? How do they work together to both identify and often raise new questions the more information you get? So a very quick show of hands. How many, and not cards, just hands, how many of you teach with cases in any kind of teaching? So a small number, 3, 4, 5, 6. Okay, so teaching with cases is a very common way of teaching in ethics. It's also very useful in teaching basic conceptual frameworks and language. And cases become the baseline against which people then are able to remember particular principles and good practices. So we're going to use a couple of active learning methods with the caveat that I'm going to start out with what I hope will be an engaging presentation from the front, because typically we would have reading behind us. And to make sure that everyone is on the same page without having provided homework, we did provide the text of a case. In the Fuller Institute, we have 5 cases. You don't need to follow along with this, but you're welcome to use it to teach. You're welcome to adapt it to things that you want to focus on. But this is the first of the cases in about the middle third of the book. So we're going to use the CART, the Low-Tech Individual Response System. We're going to use some group share, which is discussion and brainstorming at the tables. And then we're going to talk about, without actually doing, the idea of a concept map, to link common themes together and to think about relationships between problems and ideas, practices, and the concepts behind them. So how many of you are familiar with South Korean veterinarian Woo Suk-won? Most of you would have been in school when he became famous and then unfortunately notorious. Dr. Hwang was the focus of a great deal of adulation and admiration about science until he became a figure of scandal. He was a national hero in Korea, a member of the Faculty of Veterinary Medicine and Biotechnology at Seoul National University. And at Seoul National University, he was touted as being the most important scientist that university could ever see. You can see here that he featured on Time Magazine, which identified him as one of the top 100 people of the year 2004 for his scientific achievements. And here we see him, I had said I wasn't going to use the laser pointer, and I should never say never. Here we see him surrounded by paparazzi. Can you imagine yourself being hounded by the media wanting your picture, wanting your autograph? Most scientists don't think about that. And when it happens, most scientists don't know what to do with it. Huang's career had started in the genetic modification of livestock, particularly cattle and pigs, with the idea of improving both their health and their use as food products. And it was his belief, and many people's assumption, that cloning of human beings would follow from the practice of cloning animals, and genetic modification of humans could follow from the practice of genetic modification of animals. And so when Huang began his practice of genetic modification and then efforts at cloning animals, following the successful cloning in 1996 of Dolly the sheep in the UK, it was only a matter of time before he and his team began using the same techniques with human beings. However, Dr. Huang was a veterinarian, and we'll come back to that issue in a couple of minutes. He had two landmark papers in science that brought him to international prominence, although he was already fairly well known in his home country of Korea. In 2004, February, a paper in Science first reported success in creating human embryonic stem cells by somatic fluid transfer. And this was a very important contribution to science. It was something that many people have been attempting, many people have been talking about. We'll look at in a minute where stem cell therapy was expected to go and still is expected to go. And then in May of 2005, do we have stem cell scientists in the room? No? Actually, before I go any further, is anybody working in the area of stem cells? Cancer stem cells. Slightly different, not embryonic stem cells. In May 2005, he announced in an article in Science with his team that they had perfected the personalized stem cells with the genetic material for individuals who could then receive stem cell therapy for their particular diseases. And this, in many respects, was a very important target therapeutically, to be able to create individual stem cells that would not be rejected by the individual patient. And then in 2005, in August, he published in Nature a paper reporting on the successful cloning of a dog they called Snuppy. I'm not sure why Snuppy and not Snoopy and not Snippy, since we talked about snips. But Snuppy was the first successfully cloned dog after the successful cloning of sheep and other smaller animals. Now, a bit of a refresher on embryonic stem cells. Embryonic stem cells start with an embryo. And depending on the species you're looking to use, you must, to treat with stem cells, you must use that species embryo. So in stem cell treatment for humans, we start with human embryos. Fertilized egg, the egg coming from a human woman, the sperm coming from a human man. And they are allowed to expand into the blastocyst stage, at which point small stem cells have begun to form on the inside of the blastocyst, which, if the embryo is allowed to plant and continue to grow, will differentiate into all of the different tissues and organs of the body. If, however, they are captured and isolated, they can be, now, we hope, matured in a petri dish and allowed to continue in a perpetual pluripotent, if not totipotent, capacity to be used for future therapeutic use. So the idea of having stem cells is to be able to create therapies that could become any number of kinds of cells for the repair and, in the future perhaps, even even the creation from the Petri dish of new organs. And if they are from the particular individual, they would not be rejected in the way that organs and tissues are rejected when they are from a donor, even a donor who might be an identical twin. So the first landmark paper in Science in 2004 was evidence of pluripotent human embryonic stem cell line derived from a cloned blastocyst. He talked about the cloning of the embryo, the creation of the stem cells themselves, and it made huge international press. Lots and lots and lots of attention from some scientists around the world because he was the first to achieve what many people had been seeking. He talked about the fact that he had been able to clone 30 blastocysts and that creating stem cells from these in a laboratory setting. They hadn't been adapted for therapeutic use, but they had been created. Then in May 2004, the question arose, where did all these embryos come from? Many people who do embryonic stem cell research in other countries use leftover embryos from artificial reproductive technologies, from IVF, vitro fertilization clinics, where embryos are created and then either frozen or discarded because there are too many of them for implantation and the woman proceeds to become pregnant. In this case, Wang was able to obtain over 2,200 eggs from 119 human donors. And this raised some ethical questions. And it raised ethical questions particularly because Korea did not have any regulatory structure for thinking about egg donation. In particular, the way in which this raised ethical issues began unfolding even as people were commenting and congratulating Wang on the scientific breakthroughs. One of the big issues was that it had been graduate students in his laboratories who had been approached and who had consented, maybe, to having the surgery to withdraw eggs, surgery and hormonal treatment to make their eggs available for retrieval. And that was a question both of coercion and what is the appropriate interaction between students and faculty. Junior researchers also were responsible for having donated eggs. The question there was, is this a personal commitment to the research? As many scientists in the past have used their own bodies for experimentation. Or was this coercion? Then the question of payment. Should women be paid to undergo a procedure that can be harmful to them in exchange for obtaining eggs? And were they given adequate information to know what the risks were of what they were undergoing? In many cases, we would see informed consent for such donation. There was no written informed consent procedure for the women who gave the eggs that became Wang's study material. And then when approached about these questions, Dr. Wang actually said it wasn't a problem. Either he was in denial about the complexity of his own work, or he simply lied about how serious the problem was in terms of what many people thought of coercion against junior staff, faculty, and students. So in 2005, January of 2005, in response to the questions at the high level of Wang's research, the Korean government passed new regulation governing the obtaining and use of eggs for research specifically, not so much for the in vitro fertilization and reproduction, but specifically for research. Not sure where that went. The second landmark stem cell publication was the one that really raised the bar for research. It spoke to the creation of patient-specific stem cells, ones that could be used for specific patients with specific diseases. And it was the beginning, many people thought, of what would be the new field of stem cell medicine. This paper had a secondary author who was listed as the senior author. This was American researcher Gerald Shattuck from the University of Pittsburgh. Having an American author did two things. It broadened the sense of appeal to the paper. It gave many people sense that the ethical issues had been put to rest because it was no longer just the Korean system, it had to pass American review as well. And where there is international collaboration, there is often assumed to be a higher level of science. Dr. Shatton was also part of other aspects of Dr. Huang's research, including the dog that came next. So that was May 2005. In November of 2005, there began to be some whispers of a problem. And interestingly for this group of young scientists, many of the suspicions about irregular behavior came from blogs written by postdoctoral fellows and junior faculty in the institution where Dr. Huang was working. Suspicions of the fact that there were still eggs being taken from students and postdoctoral fellows and junior faculty, and not in accordance with the new rules. Questions about unethical conduct regarding the way in which the eggs themselves were used. And Dr. Shatton himself raised questions then with Dr. Huang. In November of 2005, Dr. Shatton suddenly cut ties with Dr. Huang without an awful lot of announcement. And from that period forward, there began to be a closer examination of the papers in Science, which began to find some problems, including photoshopped images and questions about the repetition of certain data points that seemed beginning to have shown good quality work. In January of 2006, Seoul National University convened an investigative panel to look into accusations of fabrication and falsification of data. And that month, the science papers were both retracted. At that point, the questions of the legitimacy of Huang's research and the huge amounts of funding it received were in everybody's discussion. And in March of 2006, the Korean national government withdrew Huang's license for conducting this sort of research and stopped all of his funding. It was discovered that both papers in Science contained fabricated and falsified data. And there was still, even after the new laws, intimate involvement and coercion of research staff to donate eggs, to provide eggs. And it was discovered that over 2,000 eggs had been used, creating 2,000 embryos, none of which obviously survived and none of which produced the results that were announced in the fraudulent papers. So Dr. Huang appeared on the cover of Time magazine again, this time on his way down. It was announced by his university that all of the cell lines had been fabricated, that none of them was true. And that in fact, none of what was in his papers was legitimate science. Now it was subsequently proven that the Nature paper about Snuppy the dog clone, again, Dr. Huang was a veterinarian, was true. Snuppy was a real clone, and that science appears to have been legitimate. At the same time, there were some serious ethical issues involved in cloning as a dog that then began to raise the question about Korea's ethical standards for research with animal subjects. There were, in the creation of Snuppy, the one successful dog clone, 1,095 canine eggs used, 123 surrogate mother dogs to try to gestate the clones, and 3 pregnancies, only one of which resulted in the live birth of the clone puppy. This raises for many people the questions of where is the benefit that is produced from the suffering of the animals and the risks to the animals who might in fact be born alive. Snuppy apparently continues to do well. It's not clear whether he's going to have the same problems that Dolly the sheep did with short telomeres and a shortened life. Now, interestingly, Dr. Gerald Shatton was not found guilty of research misconduct. He was investigated by the University of Pittsburgh, and they found him guilty not of research misconduct, but of bad behavior, sort of like the naughty child. He didn't break any official rules according to the investigative panel, but he had engaged in bad scientific practices. In particular, he had shirked his responsibility as senior author of the second paper in Science, where he, as senior author, should have been the one to verify that all of the data produced was legitimate. He, in fact, lobbied for the publication of the first paper in Science after it had been rejected by reviewers. And he had a tremendous boost in his career and his reputation, and he was able to travel the world as a famous person on the coattails of a successful Korean researcher in a way that the university found was too fond of publicity for a serious scientist. All of this was considered to be misbehavior, not misconduct. In Korea, however, there were criminal charges. An indictment in May of 2006 of 6 of Hwang's collaborators who were charged and many found guilty of embezzlement and ethical breaches, including breaches of the Korean law. They were fined, some of them went to prison. So who knows where Dr. Hwang goes? I'm going ahead of myself by one. Using the low-tech response system and A, B, and C responses, do you think Dr. Hwang should have been allowed to continue his work? So A is yes, B is no, and C is I don't know, or I'm not sure, or I'm undecided. So green for yes, red for no, and yellow for not sure. Should Dr. Hwang have been allowed to continue his work? So, pick your card out. Interesting sprinkling. We have a couple of very honest, I don't know, and I'm undecided. And I think an undecided answer is an excellent opportunity for students to begin to talk about what the tensions are in the particular case. Because clearly Dr. Hwang is a talented man. A number of people who are also convinced that no, his work should not continue. And a fairly good number of people who think he should be allowed to continue his work. This kind of mix of answers is a very good starting point for a discussion of the case with students, including sending them off to find more information about the case, create an argument for why he shouldn't be allowed to continue or not be allowed to continue, and to identify other standards by which we might make that decision. So what is Dr. Hwang doing now? He's not in prison. He's doing research. He is. He's in a private biotech company where he does his very successful animal cloning work for money. Dr. Hwang will clone your dead pet. He can make a clone out of a 5-day-old cadaver dog, as long as you keep the dog cool and moist. He can find living cells to clone to give you a second generation of your pet. Scientific benefit to this? Social benefit to this? Money to this? So, as an activity for the next 10 minutes, I'd like you in your groups to spend time talking about and writing down the ethical issues that you see in the entire Hwang case, particularly things that prove useful in your mind as lessons you would like to teach your students about the good practice of science. So talking among your groups, this is a group share. Brainstorming is the process of thinking without too much reflection necessarily, not the first thing that comes to your mind, but the sort of thing that comes to your mind when you're being creative and reflective. Talk about it in your groups. Please come up with a single list, and then we will, in 10 minutes, share the discussion topics that each of you came up with by going around the room. So, 10 minutes.